Today, we are studying about the bacterial growth curve. We are studying about the bacterial growth curve. Now, let us first know how does it grow? You know, when we talk about the growth curve, we don't mean that the bacteria grows in size. We are meaning that the bacteria, we are meaning increasing in the number of bacteria. So, the bacteria growth curve. We are talking about the bacteria growth curve. The bacteria growth curve, we are talking about, we are not, the bacteria growth curve, we are not talking about the bacteria to increase in size, but we are talking about the bacteria to increase in numbers. Now, take for the example, we can inoculate a bacteria in the media. We can inoculate take the example, if we inoculate only one bacteria. So this one bacteria will have its DNA here inside. So this DNA will divide. Now the DNA, when it is inside, you will find that it will first duplicate itself. It will duplicate, and some will be at this side and some will come to this side. Then later, it will fully divide. After fully dividing, you will find that it will start dividing slowly by slowly like this. Then later, it will result into two daughter cells, each with its DNA inside it. So once this happens, it has grown now. This is the growth we are talking about. And the time it takes from here, from this one cell, the time it takes from one cell to the two daughter cells, this time is the one we call the generation time. So we can also make some calculations from here, but we shall do them later. Let us first continue and see. Now, for the bacteria to grow, there are conditions which must be in place for the bacteria to grow. Which conditions are these? We need to have temperature. The temperature is key for the growth of the bacteria. 2, we need to have favorable, actually we have to have oxygen. We also have to have the pH, which is favorable for the bacteria we are growing. Then we also have to consider the actually water under osmotic pressure. Osmotic pressure. So let us look at one by one of these conditions. Let's start with the temperature. The temperature. Now there are some bacteria which grow best in low temperatures. Such temperatures like below. Okay, let us first see. We have bacteria like the ones we term as the cyclophilic or the cyclophiles. These cyclophiles, these ones, they grow best in temperatures below 15 degrees Celsius. These ones, they grow best below 15 degrees Celsius. They are called cyclophiles. Then there are those ones which are called cyclotrophs. These ones grow best at degrees around 0, at 0 degrees. They grow best at 0 degrees. Actually, these ones are mostly found in very cold places, like if you happen to go to the Antarctica, such places, even not only there, but it's the best example I gave. So these ones, the cyclotrophs, these ones are mostly in refrigerated foods. Actually, they are the ones which may cause spoilage of those foods in the fridge. But for them to grow, they need a mesophilic condition, as we are going to see. The mesophilic one. Let us say, let us look at the next one, the mesophiles. Mesophiles, these ones, the temperature is not too high and not very low. These ones, they grow best in temperatures like between 20 to 45 degrees Celsius. These are the mesophiles. Then we have the thermophiles. These ones grow best between 45 to 122 degrees Celsius. This one grow best in between 45 to 122 degrees Celsius. Then we have the hyperthermophiles. These ones grow best in between 80 degrees Celsius to 122 degrees Celsius. So this is how we classify the bacteria or the microorganisms basing on their temperature needs. Some need this temperature. When they go to this temperature, they don't grow. Some need this temperature. When you go to this temperature, they don't grow best. So when you are growing or inoculating the microorganism, you need to consider all this in mind. Which temperature are you growing the bacteria in? We are done with those ones which need temperature. Let us see those ones which need oxygen. So when we classify these organisms according to the need for oxygen, there are ones we call obligate aerobes. These ones, they need only oxygen to grow. Without oxygen, they don't grow. These obligate aerobes. Then we have ones we call the obligate anaerobes. These ones, when you expose them to oxygen, they will die. They don't need oxygen for their growth or their presence. Then we have also facultative anaerobes. Facultative anaerobes. For them, actually, they live with or without oxygen. When there is oxygen, they live. If time comes and there is no oxygen, they just ferment or resort to respirating without oxygen. We have the micro aerobes. These micro aerobes, these ones, they only live with low oxygen. They don't need too much oxygen. They need oxygen, but a little oxygen. So they only survive in a low oxygen concentration. They don't need too much oxygen concentration or no oxygen concentration. They need little oxygen. So we have also the aerotolerant. Anaerobes. Aerotolerant anaerobes. They are anaerobes. Fine, but they don't. But actually, they are anaerobes fine, but they can stay in an oxygen concentrated area. But it can tolerate the oxygen when it is there, but they don't use it for their manufacturing of food or what, or in their respiration. They don't need oxygen. They don't use it, although they can stay when there is oxygen. So that's how we can classify them according to oxygen supply. Let us see another need, like in the pH. The pH here, there are some which grow in acidic pH. That is five between, that's the 5.5 and below. Those ones are acidophilic or acidophiles. These ones they tolerate, they grow best in a pH of 5.5 and below. This is their pH where they grow best. Now we have the ones of the neutrophiles. The neutrophiles, these ones do best between 5.5. This is between 5.5 to between 8.5. Then also we have another kind, which is the alkali phales. These ones do best from 8.5 to 14. So when you are growing a bacteria, you need to consider all this in mind. The type of bacteria you are growing, what does it need? Does it need an acidic condition, a neutral condition, or alkali condition of the pH? So on and so on. So we are remaining with the osmotic pressure. And the water. Now, bacteria grow best in the presence of water. Bacteria grow best in the presence of water. And for the bacteria to grow well, the osmotic pressure in the environment and inside it must be well balanced. Because if the pressure inside the bacterial cell rises up, it means that the bacteria is going to burst. Now we are now inoculating. We have now known the condition is needed for the bacteria to grow. Now we are going to inoculate, putting in mind all the conditions now. Now let us inoculate and we see. Let us first have our growth curve, because we shall monitor it with our growth curve. Rate of growth. Then time. So when you inoculate, you can inoculate some bacteria in the media. Now in the media, it will first be in the lager phase. Now in this lager phase, this first phase is called the lager phase. This first step, the phase is the lager phase. Here, the bacteria is still new in the environment where you have inoculated this. So, since it being new in the environment, it is first adjusting to the environment. There is no too much increase in their numbers. They are metabolically active, but the numbers not increased so much. So, here, the bacteria is just getting used to the environment, adjusting to the environment. Now, after getting adjusted to the environment, now the growth rate will now rise. The growth rate will now start rising with time now. Time has come and the growth, and it has, the nutrients are available very well. There is low toxicity. So, there is no problem. So the binary fusion is going on very well. So the bacteria is growing. The number is increasing. So this phase where the number is increasing, it is called the lager. It is called the logo phase. Sorry, it is called the logo phase. Here, the bacteria, everything is okay. It is now used to environment. The nutrients are available, low toxicity, so the increase in the number of bacteria is rising up. Actually, we can say it is rising exponentially. And another word for logo phase is exponential phase. Exponential phase. And after some times, it will reach a phase which we call the stationary phase. This stationary phase, the number of bacteria growing is equal to the number of bacteria dying. Here there is an accumulation of wastes. Wastes has accumulated. Although bacteria are still there is still some production, but actually there is some develop growth, but the growth is little and reaches a certain time and it stops completely. So and the nutrients is now low. So there is low nutrients, too much, wastes, toxics are also there. So this stage is called stationary. Stationary. This phase is stationary. things are at the same. This phase is stationary. The number of growth is equal to the number of death. Now, here we reach a stage whereby the toxicity is too much, the wastes are too much, and the nutrients are very, very, very low. So what comes as the result? The result which come out, there will be the bacteria will start now dying away. Here it was rising, it was in stationary phase, now it is dying away. So this is the decline or death phase. Here bacteria are now dying away. Toxins are too much. Too much toxins. There is too much wastes. There is low nutrients. Most of the nutrients have been utilized by the bacteria which has grown. So it has reached a time when the nutrients are over, but wastes are too much, toxins are too much in the media, where we have inoculated this bacteria. So this is our growth curve in brief. So I think this video has been so good for you. We have learned something. Don't forget to subscribe, by the way, and like. Actually, make sure you subscribe, like, comment your comment. You type any question you want. We shall give it an answer. Thank you for watching till the end.